Hey guys, we're going to learn how to deal with some mixture problems by using a system of equations. Before we can jump into actual how to work out one of the problems, we have to understand what a solution is when we start talking about mixture problems that involves a little chemistry. So we're going to review what a solution is. Okay. All right, so I've put here three different containers, one a 50-liter container, a 20-liter container, and a 30-liter container. My 20-liter container, I'm going to fill up with acid, and pure 100% hydrochloric acid. It would burn right through a concrete floor. In this container here, I'm going to fill it up with water, pure water, 30 liters of water. So I have acid in this container and I have water in this container. I'm going to now take these and I'm going to take the acid and pour it into my 50-liter container. And I have water and I'm going to pour that in there. So my 20 liters of acid, 30 liters of water is of course going to make up a full 50 liters. Now notice I have 20 liters of acid and 30 liters of water for a grand total of 50. And what we're going to want to do is find out what percentage of acid is in this water, because that's going to give us our acid solution. So our acid solution is there's 20 liters of acid out of the total 50 liters of the solution. And the solution is basically when this is all mixed in. And so if you know how to find your percentages, okay, this is the part, this is the whole, that tells us that this is going to be 40% acid solution. So as I mix that up, you can't see where the acid is now, but it's a 40% acid solution. Okay. Now I'm going to take this and pour it back into my other two containers, understanding that this is now 20 liters of a 40% solution, acid solution. That means if I broke this down, if I could somehow break this and where we could see what it's made out of, it's 8 liters of acid and 12 liters of water. And we just do that by going 40% of 20. And that gives me my 8 liters of acid. Over here, this 30 liters of solution is made up of 12 liters of acid and 18 liters of water. Now I should write that water in here. And notice what has to happen is when I add the two acids up, the percentage or the actual stuff, the acid, it's got to equal 20 liters of acid. And when I add up the water, it has to equal the 30 liters of water. And it does. Okay, so that's what it means as solution. We'll have some acid or pesticide, or heck, it might be juice in a punch, but this is the stuff. When we say it, and when we point it out here, we're saying that's the thing that we care about, the acid. How much acid is in this? And we're saying there's 40% of it. Okay. So here's our first question. Please pause and read this carefully. Read it more than one time and see if you can make a little bit of sense of it. Okay. Okay, so hopefully you've read this a couple of times, and I know it sounds complicated at first. So let's go over it. A chemist mixes a 12% acid solution and a 20% acid solution to make 300 milliliters of an 18% acid solution. And it's saying how many milliliters of each solution does the chemist use? So they're asking how much of this stuff and how much of this stuff do we have to mix to make exactly 300 milliliters of an 18% solution. So I'm mixing some amount, we don't know, of a 12% solution and a 20% solution. So we call this the weak solution and we call this the strong solution. And you'll do this sort of stuff in high school when you do chemistry. But this weak solution, when you mix a weak solution with a strong solution, you're going to get something in between. So something in between that 12% and 20%. And indeed we do. We get 18%. Now, the thing that we don't know is how much of each of these we're going to mix to get exactly 18%. But not just exactly 18%. We want a special quantity of that. We want 300 milliliters of 18%. So that's the puzzle of the problem that we're going to try to figure out. So what we have to do is figure out exactly how much of the 12% of the weak and how much of the 20% or the strong. How much of each of these we're going to add up to get this 300. Now, I hope that you understand that no matter what, the amount of solution in each of these has to add up to 300. So we're going to make a table, and we're going to make we're going to fill this table out, and it's going to give us two equations that we'll be able to solve. Here's our situation, and I'm just representing this little column here with some information about the weak solution, or the 12%. This column will be the 20%, and we're just going to add these two to make our mixture of the 18%. So the first thing we're going to talk about is the amount of solution, or the total amount of this liquid. We know that this amount A plus this amount B, we know that the just amount of the solution must equal 300, because this is what we want. We want exactly 300 milliliters of this 18% stuff. But the next thing is we want to know the actual stuff that's inside here, in that case the acid. So we want to know the exact amount of acid in each one of these to get it to our desired solution. So let's go back to our diagram here, and what I've done here is I've separated the acid out to, just for an example here. And notice I want to know how much actual acid I need to get in this solution. Well, this is simple because we have the information we need to figure out how much acid is in the final product here. It's going to be 18% of 300 milliliters of the solution, which is just 18% of 300. That means there's 54 milliliters of acid in our desired solution. Okay, now because I don't know the exact amount of A, but I do know that 12% of A can be shown as 0.12 A. And 20% of this amount is just 0.20 B, is 20% of this amount. So we'll go back into our table and we'll fill that in. So the actual amount of the acid, and this acid, this is the stuff that has to eventually add up to 54. So it's 12% of whatever quantity our A is, our weak, 20% of B, our 20% solution. And remember, it has to all add up to 54 liters of acid. So basically what we've just done is we've created two equations. These two equations are, the first equation is just the amount of solution, that the amount of solution must add up to our desired 300 milliliters. But then the amount of acid, 12% of this solution plus 20% of this solution, has to in the end equal add up to 54 milliliters of acid. These are our two equations, and now we'll just solve these. I'm not going to spend too much time. We've actually done this one in class in a warm-up, but the first thing I'd want to do is get rid of these decimals by multiplying through by 100, in short, clearing the decimals. And now I can choose to use the elimination method, since I see that this is in standard form as well as this. I'm going to eliminate B. So I'm going to multiply through by negative 20. And when we add vertically, the B's are eliminated. I get a negative 8A and a negative 600 here, divide by negative 8. Gives me A is 75. I can plug this back into our original equation 1 and get B is 225. And what that means is A is the amount of the weak solution, which is 75 milliliters of 12% solution, and B is 225 milliliters of the 20% solution. So in other words, I need a beaker of 75 milliliters of the weak, and I'm going to add that to 225 milliliters of the strong, and when I mix those together, I will get the exact 300 milliliters of the 18% solution that I desire. Okay? All right. So here's the problem for you guys to try. I highly recommend that you read it carefully. I would set up a table. Do the best you can. We will go over this in detail. But again, try the best you can, and when you get your answer, see if it makes sense. So go ahead and give this a shot.